there's been plans for making a lot of modifications. So I have been working while on the mechanical side of that machine. A lot of details has to be taken care of. I've started working on the software side, and while working on the software side, we played with like different tools and different ways of producing the pictures, and like kind of at every step minimizing the barrier to do so. And while doing that process, also figuring out or maintaining a tool chain, so that and breaking it down at different steps, so that different people can actually use it according to their different needs, rather than like putting everything together in one piece. I've started like breaking down the software system chain into different steps. So for example, I wanted, rather than using people's stock images that is there in our archive in our servers, I wanted people to actually choose their profile pictures or the images they want to see. So basically that means that I had to give them a software through which they can actually click and stylize their way their pictures would look like in the drawing machine, and the plotter is going to plot them. So to do so, like, we have done some examples with processing, and it was like a pain in the ass to export it as SVG. So same from the web, but rather than making a standalone application as a desktop application, we decided to actually do it as a web. So I'm just going to give you a short demo of like the 3 softwares that we have made. So one of the things that we ended up doing was, so we made 3 pieces of software, which one was, for example, one Svg Creator. So it's basically a piece of software that takes your image from your webcam and then spits out an SVG where you can actually stylize different dots and spacings and play around with that. And I want to give individuals that independence to select and play with that and give me the file later. Once I get the SVG, I made another software which is called kind of like an Svg Optimizer, which is kind of like rescales and fits the SVG in plotter dimensions, because the plotter is kind of pretty big, around like 60 centimeters by 60 centimeters drawing area. And the SVG that it's going to get from the Svg Creator is not going to be that big. So how do we, you can do that stuff with, you can say with Illustrator, basically like get the SVG from these people, put it in the Illustrator, scale it up, clean it up and things like that. But I wanted to do it, have a dedicated system, because I didn't want to be dependent on like third-party softwares like Illustrator and things like that, although I do use Illustrator. And the idea came from using Illustrator itself. So I made this with a small processing sketch, which I'm going to show later, which can be exported as an application standalone later, which basically you have the options to play around with the dimensions of the drawing board and positioning it and scaling and things like that, the SVG, and then finally again exporting the SVG from there for the G-code generation. And the last step in the software was, well, not the last step, but the pre-final step is like the G-code generator. So this basically takes in the SVG and spits out the G-code. So for that, I'm using something called SVG to G-code, which is, let me see if I can find it. It should be at some point in one of my repositories, Svg to G-code, and I should mention it. Yes, so I'm using Node.js utility, command line utility. It's called Svg to G-code. Basically, you install it globally in your system, and then it takes an argument for the file, and then you give it different options. And by playing around with it, I found a suitable combination of that, and then I kind of put it in my script. So I basically ended up writing a shell script, which is called Svg to G-code, which I'm going to talk about later. this is basically what it does is it uses this library underlying, and then whatever G code is generated by this utility, it reformats it according to my plotter needs. So for example, to give you an example, is I want to home my plotter after every cycle of G code. So for example, say I make my G code, and then I want the plotter to automatically reset itself to the home position. So I basically incorporate the homing cycle G code commands on top of every G code file, and this doesn't give me that, so I basically insert it in there. And another example is like I don't need Z-axis because I'm using another catched up version of GRBL, which is from Robotini. So these are all there in my GitHubs. Basically, I've also mentioned it, I think, briefly here. Yes, GRBL servo. Basically, it doesn't use the Z-axis for the stepper motors, and I'm using the servo motors. So I'm basically like erasing all the Z-axis commands and basically using one of the Z-axis for rolling the paper rather than like dropping the pen. I'm using that with the instructions based on the GRBL servo, which is they're using the PWM pins for spindle speed control and not the dedicated Z-axis motor control pins. So far so that. So let me start giving you some demonstration of like how these things actually work. So basically, I have hosted my current SVG export my GitHub pages just so that I can distribute it within the office. As you can see, it starts up with a very basic layout of my webcam, and it's kind of a mirror feature. And I'm going to talk about that, what that means later, and like why it's mirrored and everything. So I can play around with the thresholding here. I can play around with the pixel sizes here. I'm not giving too much independence to people here to play or give it like infinite large pixels, because that doesn't make any sense. And more smaller the dots are, the more work the machine has to do. So for example, like this is kind of like an optimum. I wouldn't say this is a very optimum SVG that I would like to draw, or the machine would like to draw. And I'm going to give later a very good example of like what kind of image would be better to draw. But as you can see, like this is thresholding, which is kind of pretty nice. And I like my pixel size somewhere to be around 9 or something like that, and then play around with that one. And so this is kind of like the layout of my face, and then I can see, basically click the show SVG button, and you can see it's flipped on the screen, because here's what happens. It's kind of like a small bug, and I'm lazy to solve the bug, so I retrofitted my software style. I'm not a computer scientist or engineer, whatever. So what it does is basically it mirrors the image, so that the SVG to G code generator, when it generates the G code, it actually, what I noticed while using SVG to G code was that it was reversing or mirroring the image in the G code. So I thought like, okay, so rather than actually what I can do is like actually I can inverse or mirror the SVG itself, so that when the G code is generated, it's actually straight. So this is what it does. And you can see like the whole G code or the SVG commands here. And once you are happy with that, you can like play around more a little bit, and then see, for example, show more SVG, or okay, let's do a straight one. Okay, perfect. And then I can just download one of my SVGs. Let's just say SVG. I'm putting in my pictures, and it's, let's see if we can actually see that. And you can see it's kind of there. So that's nice. Now the picture size would be somewhere in between. Let's see, what is that? Let's check it out in Illustrator. Let's close this for a moment. And if my Illustrator opens, which is actually opening in a separate window, you can see I have, for for ease of use, my Illustrators, everything. Let's just create a new window which is in 500 by 500, just to give you a broad idea of the bed size of the plotter. And this is how small the image would be if I had to print it there. Very, very small. Now, I can like remove these things. I don't need them, but for now I'm just going to keep them. So this is the scale. Now what I want, if I want to enlarge it, I can do it here, like all that stuff, and like put it there, but just like I made a custom software to do that rather than for people who don't have Illustrator. So what I can do from here, which is, okay, I have made a small, let me check the preferences, if it runs on a bigger screen, because the board size is very big, like it's like around 60 centimeters, and if I have to convert it, like the DPI calculation, to fit it in a screen and like see it as a whole, it's very difficult. You need big monitors to see that, and that's one of the shortcomings of using this software, is you need a big monitor, which is okay. I'm having a big monitor, and like this is custom tailored for my application. If anyone wants to use it, I'm hoping they'll have a big monitor as well, or it's an open source code, so you can tinker around and like do a scroll zooming, fit in that window thingy later. These was basically done in like 1.5 days. I'm talking about. So let's try this, run and see what it can do. So I'm basically, now after I have my SVG, I want to clean it up and I want to put it in a different location and like properly arrange it in the artboard where it's gonna get printed. So as you can see, it runs in a full screen mode, what I can do is it runs with two different things. It gets the default image, which you can see is upside down for some reasons, I can move it around and I can see some coordinates changing. So if I clean this up, you can see there's this green dot, which is kind of, I'm changing with my arrow keys, and there is something which is gray area, which is like 200 by 200. This is the maximum new origin, where I want my plotters, after getting it homed, where does it want to go and set up its new home as a 0, 0, basic 0, 0. And I'm not giving the users too much independence to play around with it, because it's kind of like the best position for it, which I figured out for that specific drawing plotter machine I'm making, and you can easily take this software and like change this according to your needs. What it's gonna do is basically, it's gonna, after exporting all the needs, it's gonna export a text file with the new origins, which is gonna go into the G code later, into the G code generator, for saying to the generator that like, hey, I want at the beginning after homing to move the pen head to this position and make it as 0, 0. So in this software, what you can do is basically you can see the maximum limits with M, and it's like 20 centimeters by 20 centimeters from both the axes. Everything is in mm here. And with the arrow keys, you can move the new dimensions. So for example, I want it to be around 80 centimeters on the y-axis to 80 centimeters on the z-axis, on the x-axis. And then with WASD keys, you can actually move the image away from these axes and like position it in the whole canvas. So now, after I am happy with seeing the relative positioning of my new origin with the maximum origin, I don't want to see the maximum origin, so I can just like take it away from the screen, and then I'm just moving it up and placing it accordingly, optimally at the center position where I'm happy. And then you can use plus and minus keys to zoom in and zoom out. So I'm going to place it up here. Oh, so I forgot. This is like the default image. Now, what happens if you want to put your own SVG in here? Let's do that. Press L, and it's going to give me a pop-up. And where is my... So that's my SVG. So as you can see, it's loaded like inverse. Oh, I messed up with my origin. So I can play around with it. It's kind of big. I should have taken out those dots in the first place, but I'm happy with this right now. I can scale it up a little bit more and place it around here somewhere. And I'm good at that. And if I press C, I can unsee the origins, new origins. C key on the keyboard shows me my current new origin. M shows the maximum origin. L loads asks a new pop-up for a new image. Arrow keys move them. WASD keys move the SVG file. And plus minus keys scale it up and scale it down. Now you might have a question why this is upside down. That's because when I was writing this, it's kind of funny because it doesn't have to be like that. So when I realized it was too late in the sense that, well, let's just export it first. So I press Q, and I hope it's kind of exported somewhere. Let me see. Okay, sample.svg. It's exported here, which is also nice. So what was happening is because when I was writing the software, I was writing it. Well, I was sitting actually behind my SVG, behind my plotter, and my plotter, as you have seen in the screen. Let's just play it again. My plotter's x-axis, y-axis was this, and x-axis was this, and I basically, when I was drawing, this is going to be, this bottom portion is going to go to up, and this is going to come to down. So basically, it's going to be like 90 degree or 180 degree. It's going to be 180 degree opposite. So this is basically the top part, and this is basically the bottom part. But I was visualizing in my head and looking at the machine, and like wrote the code so fast in like half an hour and like did everything very physically what I was saying, and like drew everything on the screen upside down because I was looking at it at that same position. But like I can rewrite the software later, and like for viewers understanding, I'm just like clarifying the fact why is it like this. But later I'd actually refactor it and like put it 180 degrees, totally opposite in its true form, because the plotter is going to hang upside down on a wall. It's not going to be like inverse. Also, the G code that will be generated will go in the negative axis, so this kind of helps this visualization to see like where it's going to be when it's going to drop. That's one of the reasons also I intended to keep it like this, because most of the times, by definition, CNCs are subtractive manufacturing processes, so they actually cut stuff and cut away materials. So everything is kept in negative axis. And I wanted to keep the tradition on, and that's one of the reasons I kept everything negative. Even my GRGL is kind of customized for negative axis, and so this visualization helps me understand where the drawing would actually go, but when it's actually drawn, it's going to be upside down. It's kind of hard to understand unless you actually see perform this thing with the machine and the software. This is very custom tailored. Okay, so now I have my sample SVG here, which is something like this. Happy with this. It's kind of placed in a right position in its data, at least, not in the canvas. So then I wrote, as I told, on top of SVG to G code, I wrote my own custom script, which is called plotter G code, which actually also takes it takes a file, and then it takes the width and the height of my plotter and the pen tip diameter, basically. And it gives you version, it has help, and I've really said like this is the dependency if you need to use it. You can use, it's on my Git, which will be it will be there in the video below. But basically well, let me just give you an example what it can do, and you can install it very easily. It's just like an installer script that installs this and puts it into bin directory from where it's a shell script you can access. So plotter.g code, and then where is my file? My file is at sample.svg, which is at Svg Optimizer. So let's see. Let's bring it here. cd desktop, not shell script. It was system experiment. Svg Optimizer. So here is my sample.svg basically. So I can do is plotter.g code as sample.svg. My bandwidth is like 650 by 650 mm. Pen diameter is, let's just say, 4 mm tip diameter. And so, actually, let me just fill it up a little bit. And then hit enter. And it's going to go through a very rigorous process of explaining what it is doing at every step. And I've tried to make it very narrative in the way that what it's doing and why is it doing so, and keeps on reminding you, and with a lot of prompts and on the screen. So as you can see, converting the sample SVG to sample.g code with the tip diameter of 4 mm. Nice. And it's going to save in the same. So as you can see, it has already generated a G code here. So let's just take into a node, because if I don't kill this process, it's a node process, it doesn't execute any further, so it's kind of a bug I have to fix. It's not really a bug. But before it proceeds, let me show you what the current sample G code looks like. So there is no way you can do it here. Current sample G code looks like something like this. It's like G290 is for like mm and all this stuff, and like it has Z axis. So what I don't need is like, I don't need this Z axis from any of these. I want to replace this Z axis with my custom servo codes, which is M05. For example, here I want it to go down, for example. So I can say M03 as 003. As actually, for going down, it's my servo position is 0, and M05, according to GRBL servo, means servo 0 position. And here, if I need to get it up, it's gonna be oh no. So this is basically getting up and going to a new location and dropping down the pen and drawing the things there. So M03 as 35 means take the servo to 35-degree angle, which is going to lift the pen up, travel to a new location, and then M05 drop the pen at the 0 servo 0, and then keep drawing. So this is all doing a profiling operation. So it's like going to draw, keep drawing, keep drawing, keep drawing. So these are the things I need to modify. Remove the Z, replace all of this stuff, and it's like very laborious if you look at the length of the G code, right? So what you can do is, or basically, if I have to say, don't save. Now let me just kill this process, p kill. Now you have seen what a G code generated from SVG to G code looks like. And now I'm going to clean this G code. So it's doing that stuff. It's going to take some time. It's keeping, so dirty G code created, and now altering the G code. And I love colors in terminal, so there you go. It's going to give you prompts what it is doing. So done removing some G code bits from the beginning, like G90 and G30. I don't need them. I'm going to put them later. Now it's asking me if I want to refactor the origin. I'm like, yes, I did it in my Svg Optimizer. So I want to. And if you can see in Svg Optimizer here, press yes. Set the new origins to the multiples of 10, like 10, 20. So it's giving me an example of how I should actually set up this SVG, right? So it's saying like, okay, increase like 10, 20, it's got multiples of 10 steps. So it's also giving me like, okay, my suggestion is like 50 to 250 mm. And remember, it's also giving me prompts like, okay, my plotter size is 650 mm by 650 mm. Kind of nice ASCII plotter bed size here. So if I see my Svg Optimizer kind of gave, how do I say it? It gave me a reminder of like, okay, your new X and Y positions are 80 mm by 80 mm. So it's like 8 centimeter from x-axis, 8 centimeter from y-axis. That's going to be the new origin. So set new origin x in mm is going to be 80, and y is also 80. I don't need this anymore. So new origin set to 80, and setting. Okay, I like mm and not inches. Adding reset to 0 command. So these are all now adding up this bunch of initial sequences that I told that I need in my every G code file, which is like unlock the alarm, do the homing, go to a new place, reset there to 0, set everything to mm, and then send the G codes sequence. And yeah, so it's like giving me prompts what it is doing and how is it doing that. And now it's making everything negative axis because everything from SVG to G code was generated in positive, and I want everything to be negative. So it's doing the z-axis negative, and it doesn't matter because I'm going to remove z-axis. Then making all axis negative because I'm explaining again, like here. Why? Because it's the idle way of working with CNC type machines. And as I said, from GRBL servo, it's saying that, well, replacing every z axis up and down with M05 and M03 commands. So if you need to be a little bit familiar with like when I'm talking about GRBL and G code here, a little bit what all this stuff means, and like they're easily there on Wikipedia, so we can just like go and find this out. Done cleaning the last bits, and it's early conversion finished. Let's see now how my sample G code looks like. And woohoo! Okay, so it's very different now. It comes with like the beginning. It says G-code tweaker for plotter by data. Nice. Okay, deactivate alarm. That means my GRBL is set up to actually give me an alarm on every start of a new sequence to ask me to forcefully do homing. So what I have to do that is like deactivate the alarm, which is $X, and then lift the servo, which is like 35 degrees. Do the homing cycle. Reset here to 0, then set everything to mm, and then basically go to this new location and then reset again to 0, and then lift the servo pen again, go to the new location, drop the pen, do the circle drawing, like the profiling operations with the pen, and this keeps on going on. And wow, that's like, I did not know. And as you can see, there is no z-axis anymore here. And I'm surprised that it's actually doing, after decimal, more than 3 digits here. Anyway, so this is the last bit, and it just like stops there. And my Python script later, which would be sending all these G codes according to the people which it found on the email, would send every other G code. So after here, it'll start over with a new person's G code with this, deactivate, do homing, and all that stuff. So all these links are there on my, so this is the SVG exporter, which you have seen already working. Where are the other repositories? All the links, don't worry, will be there in the video. So this is the SVG to G code generator, and this is the Svg Optimizer. So if anybody is interested in using this, you are happy and all the instructions how to use them, and if you have processing, that's good. There's also be the binary there which you can run in full screen anyways. You can use that after using this. If you go to this repo, there will be a link for from where you can actually access it. So this is basically hosted, as I said, again with my GitHub pages, so that's that. And then you can do this, use the Svg Optimizer, re-export the SVGs, use this command line tool, which is also there, First you have to install this svg2g code, which is there mentioned in their repo how to install it, and then you have to install my script, which is very easy to do as well, and like there is well instructions how to use it. I hope you enjoy it. While now I am using while I'm actually waiting for the mechanical stuff, which has recently arrived, one of the rollers for rolling the paper out. I'm still waiting for a lot of holders for the bearings and motor controls and things like that to arrive, and like working on the pump simultaneously, which is also going to arrive today or tomorrow. And then I just did some experiments with the peristaltic pump to keep the pen kind of not dry up, and keep the ink coming in like drop by drop, kind of like every other day or so, with a human control in between. So yeah, this is like a good way of like just telling, because these people are not, these tools, I don't think anybody in the office is going to use them except the first one to generate the SVG, and the rest are tailored for my use to make my workflow a little bit smoother and easier. And it's for other plotter enthusiasts as well out there who want to actually use this and kind of like hack this together, probably a little bit more, like use it according to their own needs. If they're doing something similar, they can use it standalone like that, or be happy to hack it and use it. So that's it for now. Thanks.